Good morning, Bobcats. This is Miss Gorman. Let's get started on today's lesson. Today's lesson, we are still in Unit 0. It is Lesson 0.2D. It's the Distributive Property, one of my favorite lessons. Our objective today is students will be able to use the distributive property to express the sum of two whole numbers. All right, let's go ahead and talk about some things that you already know. All right, so you already know the divisibility rules, which help you determine if a number is able to divide by a different number. We also know how to divide whole numbers, but our most two important ones today are we know how to factor and we know how to find the GCF. So remember, we know how to list all the factors of a number, and we know how to find the greatest common factor of a number. A factor, again, is two numbers you multiply together to get a product. All right, so I'm on page 43. So this is a way to show distributive property by a model. So basically what this is saying is 3 multiplied by what gives us 15. So 3 multiplied by what gives us 15? Well, because I know my math facts, I know that 3 multiplied by 5 gives us 15. So for example, we would put 5 right here in the box. We can say that 3 and 5 are both factors of 15. All right, let's go on to the next one. All right, so today's lesson is the distributive property. Now, when I think of distributive, I think of somebody that's going to give things to other people. Like the UPS man distributes all of his packages. He brings them to them. There's big chip distributions that are giving their chips to other companies. So when I think of that, I think of this 4 is distributing to the 6 and then distributing to the 1. So I'm multiplying 4 multiplied by 6 gives me this 24. Now I'm distributing this 4 over to the 1. 4 multiplied by 1 gives us 4. All right, so we're going to do the same thing, but now on problem 12. Remember, I'm still on page 43. All right, again, I'm distributing this 4 to this box and then distributing it over here to this box. So this is basically saying 4 multiplied by what gives us 32. And this is saying 4 multiplied by what gives us 48. Well, my math facts tell me that 4 multiplied by 8 gives us 32. So in here goes 8. I know that 4 multiplied by 12 gives us 48. So I can say that 12 goes up here. All right, moving on. All right, I'm on page 37. It says, show the distributive property works using the expressions below. So remember, this 4 is being distributed to the 5 and then distributed to the 7. So we're talking about multiplying. So this shows 4 multiplied by 5 plus 4 multiplied by 7. So if we work that out, 4 multiplied by 5 gives us 20. 4 multiplied by 7 gives us 28. When I add those two together, I get 48. So it's basically the number and then parentheses, and then we have addition for this one, and you're applying that number to both of these inside the parentheses. You're distributing it. All right, let's look at the next one. The next one, the only difference is now instead of addition, we're subtracting. So we're distributing this 9 to the 7 and the 9 to the 2. And that's 9 times 7 equals 63. And then we have that negative sign. So 9 times 2 equals 18. So we're subtracting between. So 63 subtract 18 gives us this 45. All right, let's look at this definition for the distributive property. It says to multiply a number by a sum or a difference. So remember, sum means addition and difference is subtraction. So to multiply a number by addition or subtraction, multiply each number in the sum or the difference by the number outside of the parentheses. Whoa, that sounds confusing, but it's really not. So here is an example. We have A parentheses B plus C. Now this is after it's been distributed. Remember, we're doing A multiplied by B and then A multiplied by C. So this is an example. When we have two letters right next to each other, it just means to multiply. So it's really saying A multiplied by B plus A multiplied by C. All right, so that's another example of the distributive property. Once we start doing some more problems, it will make more sense. Let's move on to the next slide. All right, I am on page 37. Lou states that for the area model below, the number behind the checkered box is 2. So here's this checkered box. He's saying that 2 goes right here. Is Lou correct? If so, what must the other missing numbers be? Write a mathematical sentence that describes this area model. So if 2 goes right here, then what can I multiply 2 by to get 8? Well, I know that 2 multiplied by 4 gives me 8. What can I multiply 2 by to get 12? 2 multiplied by 6 gives me 12. So, is he correct? Yes. Remember, what I have on my screen, you need to have on yours. Now it says to write a mathematical sentence that describes this area model. So, 2 multiplied by 4 plus 2 multiplied by 6. All right. Now it says part B. Let's look at part B. It says, are there any other numbers that could go behind the checkered box? If so, what could the other missing number be? Write a mathematical sentence to describe the area model with these two dimensions as well. Okay, so that's where factoring comes into play. So on tonight's homework, you're going to have to find the greatest common factor of the two numbers and then apply it to the distribution property rule. So let's find the greatest common factor of 8 and 12. I know that 1 multiplied by 8, 2 multiplied by 4, and that's it. Let's do 12. 1 multiplied by 12, 2 multiplied by 6, 3 multiplied by 4. So the greatest common factor of 8 and 12 is 4. That means I can apply 4 right here. So 4 multiplied by what gives me 8? I know that 4 multiplied by 2 gives me 8, and 4 multiplied by what gives me 12? Well, 4 multiplied by 3 gives me 12. So I can also say that 4 multiplied by 2 plus 4 multiplied by 3. All right. So remember, tonight's homework, you're going to have to find the greatest common factor of the two numbers to write our mathematical sentence. Yes, this is correct. It could be a 2, but that is not the greatest common factor. So if you don't put the greatest common factor as your distribution mathematical sentence, you may get it wrong. So make sure you're finding that GCF. All right, I am on page 45 now. 45, number 13 says, find the missing numbers for the area model below. List all possible combinations and write the mathematical sentence for each combination. We're going to skip the list all possible combinations, and we're going to just find the combination with the GCF that I was talking about earlier. So we're finding the greatest common factor of the numbers 48 and 36. All right, so let's think about 48. What are some factors? What are two numbers that you can multiply together to get 48? Let's list them out. 1 multiplied by 48. 2 multiplied by 24, because if I half 48, I get 24. 3 multiplied by 16. 4 multiplied by 12. And 6 multiplied by 8. Let's put our little multiplication sign so we know that that's not 68. Okay, now let's find the multiples or the factors of 36, the numbers that we can multiply together to get 36. 1 multiplied by 36, 2 multiplied by 18, 3 multiplied by 12, 4 multiplied by 9, and lastly 6 multiplied by 6. All right, so if I look at all these factors, I see a lot that they share. I see that they share, I'll highlight them in green or circle them in green. They share 2, they share 3, they share 4, and they share 12. So what's the greatest common factor between these? The biggest factor that they share is 12. So we're going to use 12 as our number. So 12 goes on the outside, and 12 multiplied by what gives us this 48? Well, we said 12 multiplied by 4 if we go down here. So 4 goes up here. We also said that 12 multiplied by 3 gives us this 36. So 3 is going to go here. My mathematical sentence is 12 multiplied by 4 plus 12 multiplied by 3. All right. I'm going to go over some problems from tonight's homework. This should help you understand how to do tonight's homework. I expect that everyone completes it by tomorrow. There has been a lot of issues with homework, so please, I'm doing these example problems to help you with your homework. So let's read this first one. It says, which of the following expressions is equivalent to 9 parentheses 10 plus 7? So that's basically saying 9 multiplied by 10 plus 9 multiplied by 7. So let's see, that's exactly what we wrote out here in this first one. So we're going to check the first one. Now, if I were to do 9 multiplied by 10, I get 90. And then plus 9 multiplied by 7 gives me 63. So is that the same as 9 parentheses 7 plus 10? Yes, because addition, it doesn't matter what side goes first. Like 5 plus 1 equals 6, and 1 plus 5 also equals 6. So addition, it does not matter which order. So I can also mark this second one. This third one looks a little strange, but it just means the same thing. So it doesn't matter what side the 9 is on, it means the same as this. So this is the same, it's just in a different order. So we can go ahead and mark that one. All right, so this says 7 multiplied by 9 plus 10 multiplied by 7. And that is exactly what we said, right? 9 multiplied by 10 plus 9 multiplied by 7. Well, we said that addition, it doesn't matter the order, so this one also gets checked. Now, is this one the same? If I did 7 and distributed 7 to what's inside the parentheses, would it equal the same thing? Let's check it out. 7 multiplied by 10 gives us 70. So that's not right. And 7 multiplied by 9 gives us 63. So that's not right. So we can't mark that one. All right, what about this 10 on the outside? Well, 10 multiplied by 9 gives us 90, and 10 multiplied by 7 gives us 70, so that is also not right. And this last one, they're forgetting the second part to this. It says 9 multiplied by 10 plus 7. Well, they forgot multiplied by 9, so that one's not right. But this one, they have that. They included the multiplied by 7. All right, let's look at this next one. It says use the distributive property to find the GCF to write the equivalent expression for the given sum. So we're finding the GCF of 24 and 20. All right, so we're finding the greatest common factor between 24 and 20. Let's list out the factors of 24. I have 1 multiplied by 24. I have 2 multiplied by 12, and 3 multiplied by 8, and 4 multiplied by 6. All right, let's move on to 20. 1 multiplied by 20, 2 multiplied by 10, and 4 multiplied by 5. So the greatest common factor that they both share is 4. So I know that 4 is going to go on the outside. Well, 4 times what gives me this 24? I know that 4 multiplied by 6 gives me the 24. All right, now let's look at the sign they have in the middle. The sign they have is addition. We're going to keep that sign. Plus, now 4 multiplied by what gives me 20? This 20 that we're looking at here. 4 multiplied by 5 gives us the 20. All right. All right, that's the end of today's recorded lesson. So let's think about, what did you learn today? Today you learned how to find the GCF of the numbers and apply it to the distributive property. Don't forget that you need to have everything copied down in your math book that I did on my screen. Also, don't forget to finish tonight's homework, and if you have any questions, please don't hesitate to contact me. Thank you. Bye.